Hi everybody, today we are interpreting data in graphs, and specifically we are going to go through some examples of pictographs, bar graphs, and stem and leaf plots. So to start off with, you're going to do a which one doesn't belong. You can see that I have 4 graphs here and they are graphing very similar information. What I want you to do is tell me why each graph doesn't belong. So you can just insert a text box beside to tell me why each graph doesn't belong. Now for our mini lesson here. For our mini lesson, I've taken some EQAO style questions just to review or teach you a little bit about each of the different kinds of graphs and how to interpret them. So a lot of you didn't remember what a stem and leaf plot was, so I'm going to go over that very quickly and then we'll answer the question here. So for a stem and leaf plot, you can see that this is our data set of numbers here. For a stem, you're going to take the number from the tens column. Sometimes if it's a larger number, it could have been the number in the hundreds column or hundreds place value that goes there. But for this one, we're working in all numbers that are into the tens column. So the number in the tens column will be the stem, and the number in the ones column will be the leaf. So that's a stem and the leaf, and we're plotting those numbers. It's that simple. So for this question here, it just says, here's a list of numbers. Which of the following stem and leaf plots represent these numbers? So we're going to look through all the numbers and we can see that we have the number 43, 44, 43, 45. So 43, 44, 45. I don't know why there's a 9 there, so it must not be that one. And you're going to go ahead through all of them. So 43, 43, there's that 49 again. Oh, there is a 49. 43, 43, 44, and 49. Yes, those are all there. And then for the 50s, there's 5 with a 0. There's 50 again. 54, I see a 54 up there, and a 57. I see a 57 up there and a 58 up there. So that one looks like it has all of the numbers. We can just put our either a check mark or an arrow, or you can circle that graph for us. If you're circling it, you just want to fill it transparent, or maybe put a red circle around it. That's up to you. Or stem and leaf plot. But let's go through and just make sure the other ones aren't right. For this one, I can already notice that there's 2 45s. And if I scan up here, I am not seeing 2 45s, just this one. And down here at the bottom again, 2 45s. And if I scan here, I'm only seeing 1. So there's my check on my stem and leaf plot. Okay, let's do a quick look at pictographs. So you've worked with pictographs for a long time. Something you might not all be familiar with is looking at half of the picture from the pictograph. So here you can see in our legend, we have a legend, we have our y-axis. In our legend, we have one circle representing 10 balls sold. So if you see half a circle, you can understand that that is only 5 balls sold. Let's go ahead and mark this up a little bit so we can see how many are in each. If I go ahead along to count basketballs, then there would be 10, 20, 30, 40. So for basketballs, I would type in 40 basketballs. Let's go ahead and count in footballs. Footballs 10, 20. So I can go ahead and count in or type in 20 footballs. For volleyballs, there's just 1, which would represent 10. And last but not least, baseballs. Let's write that in. Again, 10 and 5 more. So analyzing our graph, we were able to find the total number of balls sold at the sports store for each one. Now we can go ahead, now that we know that, and answer the question, and it asks which statement about the pictograph is true. So statement 1, twice as many basketballs as baseballs were sold. So is 40 twice as much as 15? No, it's more than twice as much. So the first one, we can put an X through. It is not correct, or we can even just scratch it out with a line. Not correct. For the next one, twice as many baseballs as volleyballs were sold. Is 15 twice 10? No, it's not. Let's put a line through that to show, no, that is not correct either. Now, an equal number of footballs and baseballs were sold. Is footballs and baseballs the same number? No, that is not true either. And last but not least, the total number of baseballs and basketballs was 55. I hope this is right. Let's see. Basketballs, 40 plus baseballs, 15. 40 plus 15 does equal 55. So we can just show that that last one is correct. I am going to circle it. Again, I'm going to make it a not solid fill, and I'll circle it in red and make that a little bit thicker. You don't have to do all that as long as you're just showing me which one you know is correct. Awesome, so that's a pictograph. The third one we're going to go over today quickly is a bar graph and reading bar graphs. So all bar graphs you will see have a title. They have an x-axis and a y-axis. On our x-axis here, we have the days of the week from Monday to Friday. They're looking at burgers sold this week. Now, where are we going to find the number of burgers sold is on our y-axis. And you can see that they have they've used intervals of 10 here. So going up by 10, and each 10 is marked by a dark line on here. You can see if it's halfway between the 20 and the 30, we would estimate that to be about 25. Same over here, where it goes about halfway between the 10 and the 20. So you would estimate that to be about 15. So just having a quick look, if you want, you could put how many each of these bars represent to help you with your questions, or you can go ahead and look at those each time. So for this one, it says, what is the range between the day with the lowest and the day with the highest sales? So again, range, so difference between the two. So we would be looking at here the difference between the highest, which goes all the way up to 60, and the lowest, which was down here at 15. And we're going to do the difference between those, which is equal to 45. And I can just move that answer into here. Now, how many burgers were sold in total during the last week? To find total number, I simply go in and add up how much was in each day. And again, you're allowed to use your calculator for this. You're just showing me that you know which data to put in. So 25 for Monday, plus 30 on Tuesday, plus 45 on Wednesday, plus 60 on Thursday, plus 15 on Friday. And you can find the total of that. I'll just pull out my calculator here. 25 plus 30 plus 45 plus 60 plus 15 equals 175 burgers sold that week. And you could just pull that in to answer your question and show me your work. Now, last but not least, how many times more burgers were sold on Thursday than on Friday? So we are looking at how many times more. That's a multiplication question. When I write that out, there's multiple ways to write out our multiplication statements. We could say 15 times what number equals 60. Where did I get those numbers from? The 15 from the Friday burgers and the 60 from the Thursday burgers. We're looking at how many more on Thursday than on Friday, how many times more on Thursday than on Friday. Now we know we could also, so you could solve that using an algebra type answer, 15 times what equals 60, or you could rewrite all multiplication questions by rearranging the order. So we could do 60 divided by 15 equals, and that's going to give us our answer. So for either way that you do that here, you will see that our answer is 4. I like to think about 15s and 60s like we do on a clock. There's 4 15-minute chunks on a clock of 60 minutes altogether. So that's just one of the tricks that I like to use with 15s to help me remember that in my head. Of course, you can always pull out your calculator to find the answer to that. All right, you're going to go ahead and do some practice now with with a stem and leaf plot question, show me your work as you go if you can, a pictograph question, and a bar graph question. Good luck with it. I know you'll do wonderful.